There, welcome back to another video. In this lesson, we're going to be going over the Pythagorean theorem. Stand up for you, the Pythagorean theorem. It's a very famous theorem, and I'll write it out here. And you'll probably have recognized it, even if you've never taken a trig class before. It's obviously very famous, but what does it really mean? So basically what we have in the given part of this theorem is we have some sort of right triangle. Now what a right triangle is a triangle that contains a 90-degree angle, like this. And we usually denote that by drawing the angle with a little square. It says that if you have this triangle with leg lengths A and B, these are the leg sides here. I'll put on my pointer. So you can see this side right here is a leg with side lengths A and B. It states that if you square each one of these lengths and add them together, you get the length of this C part all squared. The C part is what we call the hypotenuse because it's opposite of this right angle. That. So A squared, the length of A squared, plus the length of B squared is equal to C squared. Now it's also important to know where this formula actually comes from. So what we're going to do is a method involving constructing a new shape with these triangles and using area to prove this formula. So we're going to construct a really interesting shape. I'm going to try my best to draw it here. I can't guarantee it will be perfect. I'll try my best. So we have a right triangle that's shifted like this. And we have the identical triangle written like this. I'm going to try my best to contrast the short leg and the long leg so we can tell a visual difference. So it's not perfect, but what we have here is these four right triangles constructed into this weird shape. So let's label some of these sides. So we'll call the shorter side A and the longer side B. The legs, right? The shorter leg A and the longer leg B. So A, B, A, B, A, B. And we'll call the hypotenuse C. Turn off my pointer so you can see a bit better. Now, the entire shape, you may notice, I'm going to get my highlighter out, the entire thing, you might notice that it looks like a square. And you're right, it totally does look like a square, and it actually is. But a lot of times we find in math, it's not enough to just say it is, we have to show it is. So, how can we show that this is a square? Well, for starters, we know that all of these four sides are straight. They're completely straight. So that's important. But we notice that each side of these triangles, so the length of each side, let me decrease the width of my marker rather real quick. We notice that the length of each one of these legs is actually just going to be A plus B. So if A were 2 centimeters and B was 8 centimeters, the total length would be 10. A plus B, A plus B. So it's A plus B all the way around. All of the side lengths are identical, so that's a really good start. And because of the given, we know that all four corners are right triangle. Or right angles, rather. So we know that all four sides are the same length. And we also know that each corner is a right angle. So because we know these two pieces of information, we can safely say that this entire area right here is a square. So how would we describe the area of a square? Or rather, this particular square? Well, we know that if we have a square with side length, say S, the area is just going to be S squared. So we just have to take the length of each side of the square, and we're going to square it. We know that the length is just A plus B. So the area of the entire square is each side length which is a plus b squared. The other thing you may have noticed is that there's another shape in here. There's this shape in the middle. You may look at that and you say, well, you know, my drawing obviously isn't perfect, but that does definitely also look like a square. And again, it is a square, but we have to show that it is. And this one's going to be a bit more difficult actually than the outside of the square. So we're going to have to look at it from a different angle. So I'm going to draw a little arrow down here, and we're going to look at it a bit differently. So we're just going to take the bottom portion of the square that we had before. I'm going to redraw it. This obviously isn't to scale, but you know, that's just because I'm a human and I can't draw everything perfectly. So we know the shorter side lengths are A, and the longer side lengths are B. Now, actually, let me make note that because of how we defined our triangles, we already know all 4 side lengths are equal. So I'll go in red here. We know that the inner triangle, we already know that all 4 sides are the same length. Now we just need to prove that each corner is a right angle. And that's the difficult part. That's why I'm drawing this down here. So I'm going to zoom in a bit so we can see it a bit better. Let's call some of these angles different things so we can tell them apart. So we'll go the angle across from A here. We'll call this guy angle big A. And the angle across from B over here on this side, we'll call this one angle big B. And that's the same over here. These are equal because the sides opposite of these angles are equal. And we'll call this angle A. So now what you notice on the bottom is that we have another angle here. And this is our mystery angle. This is the one that we need to prove is 90 degrees. We'll call this one angle X. We know that because this bottom part right here is a straight line, that these angles right here all add up to 180 degrees. So we can say that angle big A plus, so angle A over here, angle X plus angle B is equal to 180 degrees. Right, those are just supplementary angles. But now we have to look in at the triangle itself. And what we notice is that we know given that these are right angles. So just look at this triangle on the right here. We know that the interior angles of a triangle, add up to 180 degrees. So we know that angle A, which is up here, plus angle B, plus this other angle, which we know is 90 degrees, and that's important, is also equal to 180 degrees. Sorry about that delay real quick. So what I just did here is I just moved the equations from up and top to left and right. So what we're going to do is we're going to subtract, on this formula on the right, 90 degrees from both sides. Right, and this is just an equation, so we can totally do that. So we know that angle A plus angle B is equal to 90 degrees. Okay, great, so now we know what angle A plus angle B is. And in fact, if you look here on the left, we're actually adding angle A and angle B together in addition to angle X, and that's also equal to 180 degrees. So because we know angle A plus angle B is 90, we can replace this angle A plus angle B with 90 as well. So it's just 90 degrees plus angle X is equal to 180 degrees. And if you subtract 90 degrees from both sides there, you get that angle X is equal to 90 degrees. And that's our key. So we know that angle X is actually a right angle. So we can look back at our original drawing. We can safely say that these 4 angles are right angles. And because all 4 sides are length C, and we just proved that each corner is a right angle, then it is indeed a square in the middle. Now, this is just for one corner of it, but know that this would apply to all other parts. If we labeled all of these, we could prove all of them. So all of them are right angles. So now what are we going to do from here? Well, what we're going to do, I'm going to go down. I'm actually going to copy this drawing so we can reference it. So I'm going to grab all of it, press copy. Then we're going to move down, and we're going to paste it in. So we know that the area of the whole thing, so I guess of the big square, is A plus B all squared. And we know the area of the little square is C squared. So what we're going to do is we're going to take the area of the entire thing. Let me actually get this a bit larger. We're going to take the area of the entire thing. So this entire square, A plus B squared, the entire thing. And what we're going to do is we're going to take out the area of the four triangles. We're just going to like get rid of them. And what we're going to be left with is just the middle portion, just that middle square with the area of C squared. So how would we write this with an equation? Well, we know we're taking the area of the whole thing. Sorry about that again. So we're going to take the area of the whole thing, A plus B squared, and we're going to subtract out the area of those four triangles. What is the area of those four triangles? Well, if you recall, the area of one triangle is 1/2 base times height. Well, with this right triangle, side lengths A and B, the base is A and the height is B. So the area of one of those individual right triangles highlighted in blue is just 1/2 AB. Now, because we have 4 of them, we can put this 4 out front. So there's 4 of the area of each one of those triangles, which is 1/2 AB. When we subtract all of those away, all you're going to be left with is C squared. So now what we're going to do with this equation is we're just going to use some algebra. So we're going to take this A plus B squared and we're just going to FOIL it out. So remember, this isn't equivalent to A squared plus B squared. We have to FOIL it out because this is like A plus B times A plus B. So when you FOIL that out, you get A squared plus 2AB plus B squared. Oh, that's my apologies. This should be a minus sign, by the way, because we're getting rid of the area of each one of those. So now, what are we going to do with this? Well, minus 4 times 1/2, that's just going to be minus 2. So what we're going to be left with is minus 2AB is equal to C squared. And you'll notice because we're adding 2AB and we're subtracting 2AB, these just cancel. And what we're left with is the famous identity. A squared plus B squared is equal to C squared. So this definitely isn't the only way to prove the Pythagorean theorem, but this is the method that I learned from. I think it's really interesting. That's pretty much all I had to cover. I apologize I haven't been posting as much. It's just been kind of difficult with school starting up again, but I'm going to try and stick with it. And do be on the lookout for more videos. Thanks.